Okay, so here we have a new physics problem that involves the concept of work. In this problem, we have a box that's been pushed across a horizontal surface that has friction. This box has been pushed by an external force identified as P. P has a magnitude of 5.4 newtons. There's also the force of friction that has a magnitude of 1.2 newtons. And then there's the distance. The distance provided in the problem, the distance between point A and point B, and the distance is equal to 0.5 meters. That's going to be our displacement. Then they tell you that there's a kinetic energy at the beginning at point A and at point B. Now the total change in kinetic energy is it's the equivalent to the network. It's equal to the network by definition. This formula right here. Now you get that by using this formula, which is final kinetic energy minus initial. We got those values here. They tell you that the kinetic energy at the beginning, meaning point A, is equal to 4 joules. Then at point B is 5.6 joules. Now we plug in those values into the formula and we get that the total change in kinetic energy will be equal to final, which is 5.6, minus initial, which is 4 joules, and that is equal to 1.6 joules. That is the total change in kinetic energy, which is also equal to the network. But we'll get to that in a minute. Now, we cannot find the work done by P, which is what they want you to find, by the way. We cannot find that by using this formula right here. Work equals force times displacement cosine of the angle. And the reason why is because we don't have that angle. That angle is not provided. So we're going to approach this a different route, and that's exactly what we're going to do. What we can do is to find the work done by the force of friction, and that is equal to the force of friction, which is 1.2 newtons, times the displacement, which is 0.5 meters or 1/2, and then the cosine of the angle between those two vectors. In this case will be 180 degrees, simply because friction is always going against the motion, so it makes sense to go the other way, right? So cosine of 180 is going to give us -1, and so that means that we're going to get a negative value here for the final answer for the work done by friction, and that's okay. That's the way it's supposed to be. So if we plug in these values in the calculator, we get that the result, that the answer is equal to 0.6 joules, and that is actually negative 0.6. Then now that we have the work done by friction, maybe we can find the work done by P, because the total, I'm not the total, but the network, in this case, will be just the sum of all the work done by the forces acting on the object. Now, there's only two forces acting on this object right here, and that is the work done by P and the work done by friction. But there's, well, we can just ignore the fact that there's no work done by gravity, simply because the gravity is acting perpendicular to the displacement. So that means that you get a 90-degree angle between those two vectors, and cosine of 90 is 0. That is why there's no work done by the force of gravity. And that is good, because now we have everything we need. Now the total change in kinetic energy, we said it was equal to, according to our calculations, equal to 1.6 joules. So we're gonna apply that we're gonna put that into the formula, 1.6 joules, and that is equal to the network, which is the sum of all the forces, or all the work done by forces rather. Now the work done by P, which is the work that we will need, we don't know, but we'll find it soon. And then the work done by friction, which we know by now because we just found that it was this one right here. Now what we can do is simply using simple algebra is to isolate the value by the work done by P, and we get our final answer by doing that. And so by that we do simply 1.6 joules minus, well, not minus, because this is the work done by friction, which is negative already, so it will go to the other side as positive. So it will be 1.6 joules plus 0.6 joules, which is the work done by friction. And by that we isolate the value of work done by P. And so we add these two we get that the work done by P is equal to 2.2 joules, and that is going to be our final answer.